Projective Geometry, Volume 1, by Oswald, Veblen, and John Wesley Young. Section 47, Pencils and Ranges of Conics. Order of Contact. Exercises. 1. What are the degenerate conics of a pencil or range of type 1? The diagonal triangle of the fundamental quadrangle, or quadrilateral, of the pencil range is the only triangle which is self-polar with respect to two conics of the pencil or range. 2. Let a squared and b squared be any two conics of the pencil of type 1, and let p be any point in the plane of the pencil. If p is the polar of p with respect to a squared and p prime is the pole of p with respect to b squared, the correspondence thus established between the pencil p and the pencil p prime is the projective collineation of type 2, whose invariant triangle is the diagonal triangle of the fundamental quadrangle. Do all projective collineations, thus determined by a pencil of conics of type 1, form a group? Dualize. 3. What are the degenerate conics of a pencil or range of type 2? 4. Let the pencil of conics of type 2 be determined by a triangle ABC and a tangent A through A. Further, let A' be the harmonic conjugate of A with respect to AB and AC, and let A' be the intersection of A and BC. Then AA and A' are pole and polar with respect to every conic of the pencil, and no pair of conics of the pencil have the same polars with regard to any other points than A and A'. Dualize and show that all the collineations determined as in exercise 2 are in this case of type 2. 5. What are the degenerate conics of a pencil or range of type 4? 6. Show that any point on the line joining the 2 points common to all the conics of a pencil of type 4 has the same polar with respect to all the conics of the pencil, and that these all pass through the point of intersections of the 2 common tangents. 7. Show that the collineations determined by a pencil of type 4 by the method of exercise 2 are all homologies, i.e. of type 4. Exercises. What are the degenerate conics of this pencil and range? 2. Show that the collineation obtained by making correspond to any point P the point P prime, which has the same polar P with regard to one given conic of the pencil or range that P has with regard to another given conic of the pencil or range is of type 3. Exercises. 1. What are the degenerate conics of a pencil of type 5? 2. Show that the collineation obtained by making correspond to any point P the point Q, which has the same pole P with regard to one conic of a pencil of type 5 that P has with regard to another conic of the pencil is an elation. 3. The lines polar to a point A with regard to all the conics of a pencil of any of the 5 types pass through a point A'. The points A and A' are double points of the involution determined by the pencil on the line AA'. Construct A'. Dualize. Derive a theorem on the complete quadrangle as a special case of this one. 4. Construct the polar line of a point A with regard to a conic C squared being given 4 points of C squared and a conjugate of A with regard to C squared. 5. Given an involution I on a line L, a pair of points A and A' on L not conjugate in I, and any other point B on L, construct a point B' such that A and A' and B are pairs of an involution I', whose double points are a pair in I. The involution I' may be described as one which is commutative with I, or such that the product of I and I' is an involution. 6. There is one and only one conic through 3 points, and having a given point P and a line P as pole and polar. 7. The conics through 3 points and having a given pair of points as conjugate points form a pencil of conics. Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt with programming and illustration by Jim Renhold, 2019. Thank you for listening.